Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of scientific notation. This is standard 8.2c in the great state of Texas, and we are using item number 29 of the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we are looking at the density of oxygen, and it's got a very, very small 0.001429 grams per cubic centimeter. So our question is, how do we write this in scientific notation? Because 0.001429 is not really the correct way to say it. It's kind of a difficult number. So let's see if we can first figure out exactly what this is, 0.001429. And then we'll see why scientific notation is a little bit easier. All right, so that's my ones place. That's my tenths. That's my hundredths. All right, so now I've got my thousandths. 10,000ths. Got my 100,000ths, so that looks like that 9 is actually going to be in my millionths. So when I get this, I can say it is now 1,429 millionths. Yeah, you have to say the 1,000. You have to read this like its own number, 1,429, and then you have to use the place value. That's why it's kind of weird. 1,429 millionths. Very hard to visualize. So that's where we get into scientific notation. What this does is this lets us take either really large or really small numbers. In this case, we have a really small number, and just make it a little bit more manageable. And what we do is we multiply it by 10. And so it's either going to be positive 10 or negative 10. So watch what happens here. Our goal is to get one digit in the ones place, and then everything else as a decimal after that. So we're going to find that very first digit, that 1. We're going to make this our target. That's where we're going to. And we need to get our decimal over to right after that. This is where we wanted to get it to. We want it to be 1 point. So watch this. We're going to move the decimal over 1, 2, 3. So we move it over 3 times. What exactly did we do there? Well, when we are multiplying by 10, right, our number gets bigger because we are adding zeros to it. So when we are dividing by 10, right, our numbers get smaller because we're moving it the incorrect way. So watch this. All of these have this 1.429. I said we moved it 3 times. So let me start with 1.429. If I were to multiply by 10, I would move it over to the right. So times 10 gets you this direction. But I don't want to make it bigger, I want to make it smaller, which means I need to divide by 10, because that's going to move me over to the left. And I moved it over, remember we counted 1, 2, 3. So you can go either way you want to there. But you're going to get this 1.429. Since I moved it over to the left, I divided by 10 3 different times. So it's going to be this 1.429 times 10. It's always going to be a digit in the ones place, followed by decimals if required, times 10. The big key you're looking for is that exponent. Since you're dividing by 10, you're moving it over to the left 3 times, you're going to have a negative exponent. This could be negative 3. Because if I were to go like this, 1.429, and if I were to multiply it by 10 to the 3, 10 to the third, you're going to move it over to the right, 1, 2, 3. You end up with 1,429. So the correct digits, but this is completely different than this right here. So when we're getting it smaller, we're going to multiply by negative exponent. In this case, our answer is C.